Great. Hello, everybody. I'd like to welcome you to this High Tide Foundation supported marine money discussion by 4 incredibly experienced professionals on the role of LNG in the practical, economic, and equitable evolution of the industry's efforts to reach zero emissions. We are appreciative of the support of High Tide Foundation, whose own commitment to combating climate change is unparalleled in our experience. It was, in fact, High Tide Foundation's commitment to the methane pledge from COP26, which motivated our year-long examination of the clearly critical practical steps our own industry is, in many cases, inspiringly making to protect the environment. It is for that exact purpose we are honored to have 4 individuals of enormous integrity who are committed to the safe development of LNG as a major tool in the industry's efforts to reach zero emissions. The technologies, the operations by quality companies like Tote, continued industry leadership and commitment, accurate, real-time, transparent measurement, reporting, and verification of all elements of our industry's emissions footprint is critical today and will become even more critical in the months and years immediately ahead as regulatory and commercial partners increasingly look for progress. We know we are on a vital mission. Last month, the leaders of the Poseidon Principles discussed how that ambition will continuously evolve. I am extremely pleased that my friend of several decades now, Peter Keller, will take over and lead the discussions. It has been my privilege to work alongside Peter at several stops in his career, and he is one of those people who, if he asked me to walk into a burning building to save a dog, I would say, of course, without a question. Pete, before you get going, just very quickly for our audience, you will see on the bottom of your screens a Q&A option. If you have questions for the panelists, please type them there, and as time permits, Peter will try to get to all of them. Peter, now it's over to you, and thank you, gentlemen, for participating today.
Thank you, Jim. I'm pleased to say there's no burning buildings around right now, so I think we're all safe for the moment. I want to talk just a minute before I introduce the panel about LNG. LNG, as we all know, has been a maritime fuel for over 50 years. It has been in that development phase for that long, and today it is a safe, scalable, competitive, future-proof fuel that provides exceptional air quality benefits, but also sets us down the road to decarbonization. As our panelists will note, LNG provides benefits today, not decades from now, not talking about issues that cannot and may not ever come to fruition. Together with BioLNG and eventually synthetic products, LNG provides a clear pathway forward. LNG, as we know, is also gaining significant traction in the last year or two, as we see the amount of new builds that have been growing very, very significantly. Let me take a moment to introduce the panel. First is Dr. Oliver Schuller. Dr. Schuller is a senior sustainability consultant with strong expertise in the energy and mobility sectors. He holds a master's and PhD in environmental engineering from the University of Stuttgart, obviously in Germany. He has over 18 years of experience in the field. He is at Sphera. Oliver is responsible for the coordination of Sphera's energy and mobility consulting team and manages key projects in the field of sustainability and the very important life cycle assessments, so-called LCA. Oliver was also the lead author of the first and second life cycle GHG emission study on the use of LNG as a marine fuel that was commissioned by CLNG and SGMF and is available on the, both of those studies are available on the CLNG website. After Dr. Schuller, we'll hear from JP Marcantonio. It's important as we go through these discussions that we hear from actual LNG vessel operators and bunker providers. JP has kindly jumped in when Jeff Dixon of Tote Services was not able to join us because of an earlier conflict. JP oversees Tote's clean energy and LNG vessel services. This includes the world's first dual fuel LNG container vessels Tote's Marlin class, which operate to and from Puerto Rico, as well as North America's first LNG bunker barge, the Clean Jacksonville. Tote is also converting their Orca class RoRo vessels to dual fuel LNG, and JP is part of that project. JP is a graduate of Kings Point, and interestingly enough, he has dual citizenship in terms of both marine transportation and marine engineering, and holds an MBA from the University of Washington. Last but certainly not least is John Hatley. John will talk about the OEM perspective and take a future look at other things that are happening in the industry. John is the General Manager of Innovation for Wärtsilä, and he focuses on decarbonization initiatives, which includes LNG, as well as other future fuels. John, interestingly enough, examines the operational and technical energy savings and then merges environmental monetization with business investment. At the end of the day, together with Poseidon principles that Jim mentioned, the investment issues obviously become extremely critical as we look forward. John is also a graduate of Kings Point and sailed for many years as a maritime engineer. Like JP, John is a real expert with practical hands-on experience, which of course, in the theoretical world that many of us live in today, is extremely important. As Jim mentioned, after the presentations, we'll leave some time for questions. And at this point, Dr. Schuller, the floor is yours.
Thanks, Pete, for the kind introduction. Yeah, maybe since the companies of the other panelists are well known, maybe just take one or two sentences about Sphere of the company I'm working with. So maybe if you go just to the next slide, please. So Sphere is an international software data and consultancy company headquartered in Chicago, in US, and it's a leading provider of environmental health and safety, operational risk and product stewardship management software, all operating in the domain of ESG. And in our consultancy group, we help business to optimize the operations, drive product innovation, and help to increase transparency through fact-based greenhouse gas performance quantification. And that's also where we are talking about today. And if you please click to the next one, I want to take the opportunity to introduce the greenhouse gas intensity study for LNG as a marine fuel, which we have prepared for LNG and SGMF. And since the first study we performed in 2019 were quite a success with more than 3,000 downloads, we were updating the study last year and we're publishing it in April last year with the most up-to-date data. And this study was sort of, lighthouse study to provide ship owners, investors, regulators, an accurate analysis on the latest developments in the ship engine technology, as well in the supply chain. The study itself, it's based on a very detailed technical bottom-up analysis. It's following a life cycle approach, so from well to wake, following the ISO standard for life cycle assessment, ISO 14044. And it was really looking for the global average fuel supply on regional individual supply chains for the corresponding fuels. And the fuels we have analyzed, and I mean, if you analyze LNG, you have a benchmark you compare with. And for that, we were choosing the low sulfur fuel oil, maritime gas oil, the MGO and LSFO, where we also did some analysis. For the chips, we were looking at the most common engine technologies. As most of you know, there are different technologies available: 2-strokes, 4-stroke, diesel cycle, Otto cycle. And in particular, we are looking at the fuel consumption as well as the methane slip, which is a topic in this regards. What we also looked at were at the local emissions, looking at air quality indicators. And this study was then critically reviewed by 4 independent experts around the globe, having a look on the methodology applied, having a look on the data. And I think what makes this study quite unique compared to many other studies having been published over the last couple of years is that due to the association work, we had a close collaboration with many and with the key leading ship engine manufacturers, as well as with leading LNG and fuel suppliers, as you can see on the left-hand side. Maybe if you click to the next one. Yeah, what we have analyzed from well to wake were then for the different technologies, the environmental performance. And as you see on the upper left-hand side, you see the results for the two-stroke slow-speed engines. And what you see on top is the benchmark for the very low sulfur fuel oil with an 0.5 sulfur degree content, which results in 688 grams CO2. And on the bottom, you see the two LNG engine technologies, how they compare with, and you see that there's an advantage of, depending on the technology, 14 to 23% compared to the conventional fuel oil engines. What you also see is that the combustion in the engine, and that's the green part of the bars, it's the dominating part, while the supply chain has a minor role. And if you look on the discussion about CO2 and methane, you have to look at the right-hand side, where you see the single individual greenhouse gases contributing to the global warming potential. You see that the main part is coming out of the CO2, while minor parts are related to methane. And similar as for the two-stroke engines, we analyzed the four-stroke engines. And if you please click to the next one, you see similar results where you have advantages of using LNG compared to conventional oils in the order of 6 to 14%, where this is a little bit lower than the two-stroke simply because there's different engine technologies in place, and that's resulting to a little bit less advantage. But keep in mind that around 70 to 75% of the international shipping, of the global shipping, is deep sea shipping and belongs to two-stroke, while the other 25% is a four-stroke shipping. Where we have, then maybe just if you click to the next one, I don't want to go too much in detail. I think the study are available for download, and also the slide deck. Where we also had a look, and I mean, as I said already at the beginning, methane emissions are a topic in that context. And what we also have done in this analysis is looking, okay, what is expected to be improved over the next years? And as you probably know, there's a lot of initiatives going on the LNG, on the fuel, let's say in general, supply chain in terms of reducing the methane emissions. And by reducing the methane emission in the supply chain over the next years, that will for sure also impact then the overall greenhouse gas performance for the supply. And by reducing the methane emissions by 35% in the supply chain, that will result in a well-to-tank emission reduction around of 9% in 2030. The same applies for the LNG use, so the usage in the ships, in the engines. And here we see that, and we did some interviews with some ship engine manufacturers, and they have already demonstrated and are further working. And I think we have experts here on the panel which will probably elaborate a little bit further on these aspects. Demonstrated, the optimization, improvement in the design, developing solution, such as catalyst to further reduce the methane up to 90%. And I'm curious to hear later how this development are ongoing. But there's also a lot of, in discussion, in improvement, how things can to be improved. And if you bring these two aspects together, so the improvements in the supply chain as well as in the usage, that could further, reduce the carbon footprint as LNG for marine fuel. And as you see in the table, there are, advantages which can drop from, as we said, depending on the technology, from 6 to 23% up to, 24%. But across the different engine technologies above the 20%, as indicated in this table. yeah, what we concluded, and maybe please to the next one, is that the analysis which we performed, and I mean, the whole study is a 160-page report with lots of details and lots of information and numbers, and it's really a technical bottom-up analysis. It's probably also too short in 5 minutes to go in too much detail, but feel free and invited to have a read on that. And you know, it was looking at really at the most common ship technologies in operation. It was looking on gas and on oil-based engines, so fuel oil engines. It was taking into consideration the fuel consumption, the methane slip, and by comparing it by one and having the latest up-to-date, accurate data for the different ship technologies, and comparison was possible. It was also looking, even not shown here, air pollutants, where LNG shows quite some advantages compared to conventional fuel oils. And it's said based on primary data which we have collected. So most of the efforts in the project was undertaken to really collect the primary data, going to the different companies and collecting the data and bringing them into such an analysis. As said, it was following the ISO standard. Also, this is quite specific. So there's an ISO standard for life cycle assessment since 30 years, developed and applied in industry since also 30 years. And by conducting our study, we were strictly following the standards from a well to wake perspective, and it was critically reviewed by 4 independent reviewers across the globe. Also, giving some validity to the results and conclusions drawn from that. And as said, and the creator of the study was to be complete, to have really all the engines, to have quality assurance, and to be objectives. And that leads to the conclusion that LNG is a viable alternative marine fuel, an alternative to conventional fuels which are in the market today. And maybe if you just move to the last slide, and then I'm closing as a sort of takeaway. So, as said, LNG is a fully compliant, viable solution which is available on the market. So you can go and bunker it today. It helps to reduce the greenhouse gases by up to 23% in the international shipping context. And it's therefore also contributing to the IMO greenhouse gas reduction target. And LNG as a gaseous fuel is also contributing to improve the air quality, in particular important for ports and coastal areas. And by the help in ongoing optimization in the supply chain, as well in the engine technology developments and further enhancements in the benefits of LNG by reducing the greenhouse methane slip emissions. And as a sort of outlook, LNG is replaceable by BioLNG and synthetic LNG without major adjustment to the engine. So it can be replaced, and fossil LNG can be more or less phased out by just adding bio and syn to the fuel mixes. And then last but not least, LNG helps to contribute to the IMO targets and lowers the carbon intensity of international shipping. As said, the whole study is available. There's some, 15 pages summary plus the 160 full analysis. If you're interested in all the details, the link is here. You can download. And if there's any question, feel free to reach out to us. Thank you. Back to you, Pete.
Thank you, Oliver. I would just like to make one comment on Oliver's work, and that is the importance of current data. So much we see today, so many studies we see today continue to use data from 3, 5, 7, 8 years ago, and they continue to repeat that old data. The beauty of Sphera's work and Oliver's work is the fact that we used current data, 2021 data from direct sources. So that's really important when we consider what's going on in terms of the opportunities and the world around us, and things that the people may or may not be suggesting in terms of what is real and what is not. And we all know that technology continues to move forward. And certainly just the difference between the first and second studies clearly indicate the technology is moving forward in terms of LNG life cycle work. Moving ahead, I'd like to introduce again JP, who will talk about actually operating ships and operating ships with LNG. Remembering also that Tote is one of the early innovators, having built the first LNG powered dual fuel container ship anywhere in the world, and then leading with bunker barges, certainly in North America. So with that, JP.
Yeah, thanks, Peter. Good morning, good afternoon, good evening to everyone out there. Peter and Jim, Tote thanks you for the opportunity to present at this webinar. It's certainly a privilege to be here today with industry partners to discuss LNG's unmatched scalability and emissions profile, especially its transformative use as a marine fuel. Next slide, please. I just want to give a quick overview of Tote. So the Tote Group is based in Jacksonville, Florida. We're a premier US-based domestic carrier, and our roots date back about 45 years when the SS Greatland made her inaugural voyage from Seattle, Washington to Anchorage, Alaska. We're made up of 3 vertical business units. So the first is our maritime companies, which is Tote Puerto Rico, where we operate a trade between Jacksonville and San Juan, and then Tote Alaska, where we operate a trade between Tacoma and Anchorage. Second, we have our services division, which I'm a member of. We do crewing, technical services, ship management, and vessel construction management. And also our LNG expertise is housed in Tote Services. And then our third is our terminal group, which supports our terminal operations. Next slide, please. I just want to start with a quick overview of Tote's LNG projects very briefly, which consist of 4 primary elements. So first, constructing the world's first LNG powered container ships, our Maryland class vessels, as seen in the upper left on this slide. Next, constructing North America's first LNG membrane barge, the Clean Jacksonville, and that's featured in the center. And then converting our Orca class vessels to LNG, which is configured on the upper right. You can see our LNG tanks, which we affectionately call pickles, on the top deck. And then finally, the 4th element is we worked with partners at Jax LNG and Puget LNG to establish small-scale on-the-water liquefaction plants featured at the bottom right. Tote's success in LNG bunkering is aligned with our core values, which is a vigorous safety culture and continuous improvement. Next slide, please. So Tote's historic use of a marine fuel, it began in Jacksonville with the vision of my fellow panelist, Peter Keller, who was an executive at Tote at the time. So we all know that in 2008, IMO decided to cut the sulfur in marine fuels. So Tote was faced with the challenge of designing our next generation of ships. We work with partners across the globe on the ship design. We had to put together the infrastructure to support the fueling operations. And we work closely with Flag State, United States Coast Guard, ABS to bring this reality to a dream. The results, by 2015, Tote delivered the world's first LNG powered container ships and started fueling with the LNG skid. The next year, we delivered the world's second LNG powered container ship. In 2018, the first LNG bunker barge in North America, the Clean Jacksonville, started delivering LNG to Tote. Next slide, please. So our focus has always been to meet or exceed the regulatory requirements and improve the environment for the communities we serve. And like Peter said at the beginning, we wanted to do that immediately and today. By switching our Marlin class vessels to using LNG as a marine fuel, we've been able to exceed the regulatory requirements. We use half as much fuel, we carry 70% more cargo. Greenhouse gases have been cut by 62%, or 120,000 metric tons. And to put this in perspective, that's 26,000 cars on the road annually. An interesting fact is that when we first started operating our vessels, we were as high as 5% MGO pilot oil. Through rigorous testing, through working with the OEM, we've been able to reduce our MGO pilot oil to closer to about 1.25%, which results in even better environmental performance. Next slide, please. This slide depicts our 2 bunkering solutions. On the left is our interim bunkering facility, or the bunker skid. The IBF skid is a United States Coast Guard approved facility that has the capability of loading over 1,000 cubic meters in 10 hours, making it ideal for any mobile bunkering solution. The skid was primary method prior to the Clean Jacksonville coming online in the Port of Jacksonville for Tote's Marlin class vessels. And on the right, as I've mentioned before, is the Clean Jacksonville, which is North America's first LNG bunker barge. Tote Services, my company, was the driving partner behind the project. The Clean Jacksonville can bunker 1,000 cubic meters in the span of 4 hours, with the customers conducting simultaneous operation. To date, we've performed over 200 bunkerings, including third parties, and we've managed to continue with the simultaneous operations of third parties also. Tote operations teams were leading the way for clean energy bunkering solutions here in North America. And I want to point out a few other facts about Clean Jacksonville. She's a membrane tank with 2,200 cubic meters. She's fully automated with a reliq system for boil off gas management. And then she's also designed to be fully unmanned, so it requires minimal personnel to complete a bunkering. We're typically able to do a bunkering with 2 personnel aboard the vessel. Next slide, please. Tote is committed to using LNG now and into the future, realizing that the fuel is a path forward. We're currently investing in our 2 Orca class vessels, which operate between the Tacoma and Anchorage trade, and we'll be the first company to retrofit an entire fleet. The Orca conversions will be completed in Q2 of 2022, so just right around the corner. We'll be complete with our first conversion and operating on LNG, and then our next conversion will start in 2023. Next slide. First, I'd like to point out, I want to thank GTT for providing the graph. They're our partners and friends. This graph demonstrates the pathway towards decarbonization through bio and synthetic fuels. LNG is not a transition fuel. As Pete says all the time, it's a fuel in transition. So let me provide a quick example. In September of 2022, RNG was supplied to the Marlins through our partners at Jax LNG, demonstrated that clean LNG can be integrated now. Produced from the decomposition of organic waste, that BioLNG is compatible with existing natural gas infrastructure and provides practical and replicable sources of energy that mitigates and repurposes those carbon emissions. From the graph, we can see that LNG already provides commercial benefits when compared to emerging alternative fuels and traditional fossil fuels. We can also see the progression ends with synthetic LNG being cost-effective and as environmentally conscious when compared with other emerging fuels. ELNG can be dropped in utilizing infrastructure, reducing upfront capital costs and the risk for a reliable supply of clean energy. Based on these significant investments Tote has made to date, we're well positioned to continue our leadership position in the marketplace in the clean fuel revolution. Closing slide, please. In closing, thanks for allowing the opportunity to share our experiences. We're proud of all our historical achievements we've made with our exceptional partners, and we certainly look forward to questions. Thank you very much.
Thanks, JP. Obviously, there's a lot going on in the tote world as regards LNG, and thank you for that. I'd now like to move to John Hatley from Wärtsilä to talk about what the OEMs are doing and what some of the future cast issues might look like. John?
Thank you very much for the opportunity to be here today. We're very appreciative of this opportunity to speak on LNG as a fuel and some of the great efforts Wärtsilä has going on to reduce the emissions, particularly the methane slip. Next slide, please. Just as a signpost in the market, and then I'll only have a couple slides here. This was announced in the middle of November that Wärtsilä has for 2-stroke engines a new process that reduces to negligible levels the methane slip. This is actually neither an auto process nor a diesel process, as the thermodynamics now has a third new medium pressure process where the gas is not used, rather it is used as an ultra cold liquid injected into the combustion chamber. So there will be something new in the thermodynamics books for us to all study. In mid-November, we announced this was moving forward, and it's been already some years in the development stage with many millions of dollars and research hours put into it on the test bed and research as well. MOL has stepped forward to help, MSC has stepped forward to help prove this technology in a number of their ships. At the bottom of the page, you see a hot link. This hot link takes you to not the November, but the January update of only a few weeks ago on this status of this breakthrough opportunity. This, I think, is a strategic change in the marketplace, helping to remove once and for all the methane slip as an issue off the table. Good for any brand of two-stroke engine, be it dual fuel or the two-stroke higher pressure. So WinGD and MAN can utilize this as well as the Mitsubishi two-stroke engine. This will be serviced through our Wärtsilä Global Sales Services Network. We have over 170 facilities throughout the world providing services on board ships. The technology will be available very soon. And as I said, the pilot project with MSC is going forward at this time. Next slide, please. We also want to talk a little bit about how you're future-proofing with LNG as a fuel. We heard a bit about the drop-in using BioLNG and synthetic LNG from the previous speakers. This is real and is going forward. At Wärtsilä, the engineers like to talk about it, why it is so neat, and it in nano details about features and benefits, how it works, how it is great, and how you need more it. Just be clear, reciprocating engine technology today and in the very near future will combust those future fuels before they're available. Some other milestones. We've been in LNG for more than 25 years. Biosynthetic methane, verified in 2003, nearly 20 years ago. Methanol, verified in 2015 with the Germanica, who's now been operating 7 years on this fuel with a 4-stroke engine. Ammonia, validation going on this year. Hydrogen, validation by 2025. The hot link to this article and several other technical things are shown here. Please refer to it. And our website has a lot of other information. But as engineers talk about flexibility, today, there may be some engineers in the audience, but I think this is marine money, meaning we have a lot more bankers and financiers involved. So let's just translate that to what it means in the financial circles is a real asset option. We all know that in times of greatest uncertainty, and certainly there's a lot of uncertainty now with regulations on emissions, what the banks are doing and their voluntary side of the side and principles, what the cargo charters are doing with Sea Cargo Charter, what the insurance industry is doing. All those are voluntary industrial shapers. And then the IMO with regulatory changes on the A, B, C, D, E ratings on carbon intensity. Times are very uncertain, technologies and fuels, and on and on. A real asset option has the greatest value in times of uncertainty. Certainty breeds investment, and clarity allows capital to flow. To meet your business windows now, with new opportunities coming in the minimum time and minimum expense, think of flexibility really as a real asset option. And by future risking and de-risking your future investments against the rapidly changing, fast tempo of regulations, technologies, and fuels in the decarb era, consider LNG as a very strong, safe, clean, and even cleaner now fuel going forward with the drop-in flexibility of bio and other synthetic fuels to make a big difference between now and mid-century. And remember, all of the other fuels we speak about as future fuels require 4 things. The 4 A's: abundance, availability, affordability, assignment. Assignment is the toughest. It refers to the welder wake. Is it black, blue, or green? And all of these future fuels require renewable electricity to formulate it: wind, solar, possibly hydro. And also understand marine is perhaps the small portion of the entire market when road and rail are perhaps 20 times larger in magnitude. That's what I got to say for a quick intro. Thank you for the opportunity to be here today. Back to you, Peter.
John, thanks so much. I think John's 4 A's are always a very interesting way to look at what's going on and what really the future of maritime fuels is going to look like. At the end of the day, as I said earlier, I think there's a practicality issue and certainly an issue of acting now as opposed to acting decades from now. Because between now and when some of these other what I refer to as magic elixirs are available, there's a lot of time that has to take place and a lot of technology and a lot of changes that have to take place. In terms of questions, I did note one question on the EU taxonomy. Certainly those of us that are watching the EU understand that their Fit for 55 program is very far reaching, is still frankly in being formulated. There are many open questions and areas that where the regulations do not seem to totally jive. There's certainly a lot of political issues going on, and certainly the very unfortunate situation in the Ukraine right now is not making any of that easier or easier to discern. At CLNG, however, we are fairly positive on some of the changes that we have seen and some of the changes that certain MEPs in the European Parliament have indicated they will support as it regards LNG. And I think we will see when the final packages come out and the final regulations come out that LNG will continue to take its rightful place among important fuels going forward. I hope that is somewhat responsive to the question, but again, as I say, at this point in time, it's very, very difficult to figure out what's going on. John, would you? I have another question here. Talking about your 4 A's, would you just run through those for a minute or two, but a little more slowly, so perhaps people can write them down, and
Sure.
we'll hear others use them in other forums in the future.
Okay, sure. The 4 A's. Availability is second. First is abundance. So it's abundance, availability, affordability, assignment. Abundance is quite obvious, and that goes to the question of scalability and how fast to make it available. That helps cut through the gist of how soon, how much, and when and where. Next is affordability. They all require renewable electricity, either solar, wind, or possibly hydro. That is in competition with all the other industrial users, and don't forget about road and rail. Probably a magnitude's much larger than the marine marketplace. So we will be choosing what others have found to be their decisions. But the most difficult of all those 3 A's, abundance, availability, and affordability, is number 4, assignment. Assignment is the toughest because it has to measure throughout the entire evolution of well to tank to weight, everything around that fuel as a sustainable. Is it black? Is it blue? Is it green? Well, black is hydrogen. Excuse me, it's from a source where you're using today's fuels of carbon-based. Blue is in between and transition, but green is obviously the cleanest of the 3, and it might even be a negative on the carbon side. Black, blue, and green. That's the toughest availability. Excuse me, assignment. So those are the 4. Hopefully I haven't mixed up. Abundance, availability, affordability, assignment.
Thanks, John. Again, a very interesting way to look at it. There's another interesting question on the extent to which owners with dual fuel ships are switching from HFO to LNG, or perhaps in Europe right now, at other places around the world, LNG back to HFO as a function of market conditions. I have not seen any data yet. I think it's way too soon to expect that there would be any data on that. I have talked to a couple of ship owners that are obviously very concerned right now, especially in Europe, for LNG availability. But whether or not they have actually switched from LNG back to a heavy fuel, or whether they're hanging in with available supplies, I really don't know. And again, I think it's too early. Dr. Schuller or John or JP, has anybody heard anything about that? No? Okay. There's another question here about the advantages and disadvantages of LNG when compared to other fuels. I don't think we have the time to go through all that here in this forum, but let me just say a couple of things. There are a number of really important vessel operating issues. The first is always safety. And I think we all understand that there are significant safety issues with some of the other alternative fuels being discussed. And we cannot take short shrift of safety, especially when we consider we have seafarers in enclosed spaces over long stretches of ocean, and in very confined environments and engine rooms and the like. And certainly John and JP can talk more eloquently about that. As ship owners and operators, we also need to be concerned about energy density. And we know that many of the alternative fuels do not have the energy density of LNG. In fact, they're about half, which means you have to carry twice as much for the same voyage, which means you're carrying less cargo. And then, of course, there's always the issue of pilot fuel with some of these alternative fuels. And I will leave it to John or JP or Dr. Schuller to jump in and talk about what we know about pilot fuel requirements for some of the alternative fuels. Don't everybody jump in at once.
Yeah, I guess in my slide, I don't know about ammonia, but with LNG, we're down to about 1.25%, sometimes as low as 1%. We're looking to even improve that even more. I'm not certain what it is for ammonia, and probably John in hydrogen could probably answer that question better.
Yeah, on ammonia, a lot of the four-stroke world is progressing, but the ammonia is difficult to get initializing of the combustion process. So there, the pilot fuel is still higher than people would want it to be. Obviously, that distracts from its overall emissions profile. But today, it appears that it's somewhere in the 20% to 30% range of a pilot required, depending on circumstances, the load on the engine and whatnot. These will be improved, but right now that's far above where we would want to be in the very, very low single digits. I think, as JP said, much closer to 1% is where we'd like to get to. But that's moving rapidly forward. So perhaps in a few weeks, there'll be better news.
Thanks for that, John. It's interesting when JP talks about 1% pilot fuel. I remember when the Marlins were first designed, and we were looking at with those first low pressure engines. I think the estimate was that pilot fuel would be 3 or 4%, and now it's down to 1%. So it really shows what happens with technology over time as we look to solve certain issues like slip. There's one last question before we think about closing this up, talking about carbon capture. I have to admit that I am not very well up to date on carbon capture. John John, can you take a
Just
strike of
briefly,
where we
because
are with carbon capture?
I know we're in wrap-up mode, so just briefly, Wärtsilä has done some carbon capture work, and we have, through our scrubbers activities, research and development in this area. The big problem is that on land, it is a proven technology for places like refineries, where you have huge footprints to put these things in place. That's the problem. Right now, the size of the units that are in use are gigantic, and we've got to have a much more compact, smaller scale, but still effective unit for ships. So this is the real problem right now, and maybe there'll be some breakthroughs, but right now we're working on that, and we have experts from our scrubber side that think a breakthrough can happen, but it's going to have a huge reduction in size, quantum reduction.
Dr. Schiller, do you have anything to add to that?
No, I think it was well said. And I mean, the carbon capture is one hand side for the ships, but it's also for the supply chain where a lot of greening is taking place, all than the fuel supply. And it's not just only the carbon capture, it's also using, green electricity to supply LNG and so on. So that's also something where some reduction in the carbon intensity of the fuel is expected to come over the next year through carbon capture as well as electrification in the supply chain.
Good. Thank you so much. In closing, before I turn this back to Jim Lawrence, let me just also state that, as I noted on the chat, and as we talked before, an awful lot of this material is available at clng.org, as well as another very detailed study done by the University of Delft in the Netherlands on BioLNG and the availability of bioproducts, sustainable bioproducts going forward. And I noticed my friend Zach from SGMF is also on the call, and certainly the SGMF website has a lot of very interesting and informative information as well. So with that, thank you everyone for your attention, and I'll turn it back to Mr. Lawrence.
Thank you, gentlemen. Thank you all very much for the very stimulating conversation. And I'd just like to say that in our collective global commitment to meeting the emissions objectives established by science and governments and regulators, it is important to stand sort of shoulder to shoulder, confronting the numerous challenges, safety, economic, technological, geopolitical, policy, and not least in terms of global equity. And so I'd like to thank our 4 participants today, Oliver, JP, John, and Peter, for their commitment at work and also personally. But I'd also like to thank all of you, each and every one of you out there who joined us today, for the chats, for the questions, and for your willingness to share links as we move forward. It gives me great hope, actually, for the future. So thank you again to High Tide Foundation for their support, to my colleagues at Marine Money. And I would just like to extend my most fervent wishes for the peace and safety ashore and at sea of all Ukrainians. And to leave you with the fact that there will be a replay of this available shortly. So until next month, gentlemen and ladies, everyone out there, thank you very much. Godspeed, and we'll see you in the future. Bye, everybody.
Thank you. Bye.